Okay, so, now I made a mistake here. I won't even say what I did, but it should have been negative 194 here. So we would not have gotten zeros here. Okay, so zeros I wrote down. Shouldn't have been there. Okay, so this is 11 and a half, which would have been a zero. Not worried about it. Okay, because what we're trying to do is illustrate how this works. So if we work it out for what I should have written down with a negative here instead of a plus, okay, it all works out, and you got it. Okay, the vertex is going to be at x equals the negative of negative 12 over 4, okay, which is going to be 3. And there was a question about why I had a 12 here, and it's supposed to be a negative b, right? But of course, b is negative 12, so negative b is plus 12. So you want to, that's a common error I make myself sometimes, okay? Of course, I make a lot of errors that you don't. So. Okay. So, again, we get the vertex at x equals 3, and we plug that into the equation, and actually we should have been using this equation. 2 times 3 squared minus 12 times 3 plus 13, and that does come out negative 5. You get 18 here, you get negative 36 here, which is negative 18, added to 13 gives you negative 5, okay? And incidentally, those are not where the zeros would be because somebody worked out the zeros. The main point thing then, in this form, we see the vertex is 3, negative 5. And in this form, we see the vertex is 3, negative 5. Because again, 3 is what makes this 0. Okay? And when we do that, we get negative 5. And then the table hopefully helps demonstrate how that works. Okay? So what we're doing now with the problems that I assigned, let's just work another one through. I'm going to work it through quickly because we've seen the details. We don't want to take a long time. So if we've got, let's say y equals negative 3 times x plus 5. We're going to start with vertex 1. Okay, sorry. Let's just say we've got this. Okay? So, we work it out. Okay, carefully, AC is negative 4. Negative 4 times that is plus 24, so that's what we're going to get. I'll do my arithmetic right. That's it. Almost down to negative. Okay? Get the square root of 125 is pretty close to 10.2. And then negative 9 plus 10.2 is 1.2. And 1.2 over 6 is 0.2, but it's over negative 0.6. I think we get negative 0.2, or negative 19.2 over 6, which is 6.2. Negative 6.2. okay? And if, wait a minute. Plus 0.2 or negative 6.2, okay? And it's not 6.2, it's 3.2. Divided by 6, add the 6 in my hand. 6 goes into 18 3 times, and then maybe 1.2. Okay, so there we have the approximate values, okay? The axis of symmetry is x equals negative 9 over negative 6, or negative b over 2a, which is right here in the quadratic formula. And that's 1.5, and that checks out with these two zeros, because if you average the two zeros, you get the number right in between them. Or if you add 2 and negative 3.2, you get negative 3, and positive is negative 9 over negative 0.6, and should have been negative 0.2, positive 3.2. Figuring out the steps, I might have noticed, okay? So there we have it. And you can easily get this. You need a calculator to get to 0.2 and 3.2. But other than that, every step you can do easily. Okay, so I really should write this as y equals f of x. So when I talk about f of 1.5, you know what function I'm talking about, right? Okay. Okay, 1.5 squared is 2.25, 3 times that's 6.75. 9 times 1.5 is 13.5 plus 2, and I'm pretty sure of all those numbers. Okay? So that gives me what? Now I gotta be careful here. 0.75 and 0.5 gives me 1.25. And then negative 6 and 13 is 7, and 2 is 9. And 1.25 gives me 10.25. Okay. And let me double check, 15.5 minus 7. It's not right. 36 and 13 is 7. 2 is 9. That's a negative 1.75. Okay. Glad I checked. Just pretending to make these mistakes so you know to check yourself. Okay? It's negative 0.75, so it's a negative 0.25, so it's going to be 8.75, and that would be 15 minus 15.5 minus 6.75. Okay, so there we have it. So, if I ask you to put this in vertex form, you would now pretty much have it. You know the coordinates of the vertex. So A is your coefficient of x squared. Okay? A is always the same as the A here. This is a capital A, this is a small a. Capital A is not always equal to small a, but when you're looking at vertex form and general form of the quadratic, They are, because this big A is a coefficient of x squared. When you expand this, it's a coefficient of x squared up here, so it has to be the same. Okay? So y equals -3, then just times x minus the x coordinate of your vertex, which is 1.5 x squared, and then plus k plus 8.75. Okay? And then we check, we expand this to be sure that we get this. -3 times x minus 1.5 squared plus 8.75 is -3 times x squared minus 3x plus 2.25 plus 8.75. Okay? And I'm not going to do the rest of the arithmetic, but I'll do it in my head real quick. But let me, okay, -3 times x squared gives you what? -3x squared, good. So far, so good. -3 times -3x is what? 9x, isn't it? -3 times -3 is 9. Okay? And then we got to multiply the 2.25 by -3. That gives us -6.75. And when we add that to 8.75, we get 2. Okay? Now you can work that out. But that confirms that that's the original, so it checks. Okay? Now that's a process I want you to be able to go through. Or the process I went through here, which is actually in a lot of ways easier. Just expand the vertex form. Now first off, read off your vertex, 3, -5, okay? Then expand it and do what you already know how to do, which is what we did here. Okay? Do that much with quadratic functions, that gets you by rather nicely. Now there are a few finer points that you want to know if you want to ace it, but that would be work just to know that much about quadratic functions. Okay?